and minus b. All right, so that's not too bad, right? Now we can solve for a, again, just figure out which one goes where. And notice, again, I can eliminate the a's just by multiplying by negative, so that's exactly what I'm going to be doing when it comes to it. So I'm going to have now this. So I'm going to have negative 5 is equal to a plus 3b. And I'll just pop a negative, so 0 minus negative a plus b. So I have negative 5 is equal to cancel 4b. So b is equal to negative 5 over 4. Okay, so now we have that so far. Oop, quick mistake. I am so sorry. This is supposed to be 3, not a 0. That changes everything. So this is now a negative 8. Sorry, yeah, something was really off. Negative 8. Oh, so nice. B is actually negative 2. Oh, perfect. Okay. Sorry about that. I forgot about that. Negative 3 goes here. Okay. Now we have that. Now let's go backwards. So plug in negative 2. Plug it into, where we went? Let's see. No, let's do the first one. So we know, plug it back into here. So we have 3 is equal to a plus minus a plus. Subtract it over. A is equal to 1. So we got 1, negative 2, and then finally we can find c. And c is probably easy if we just do it here, right? So we know 0 is equal to 1 minus 2 minus c. So this is 0 is equal to negative 1 minus c. So c is equal to negative 1. Okay. Lots of fun stuff, right, when it comes to it. All right, now that we have that, finally, we can integrate as best we possibly can. Okay, so let's go back over here. So we have a, which is 1. So we have the integral of 1 over 3x minus 1 dx plus, I'll put just negative 2 on the outside, negative 2 of 1 over x minus 1 dx, and then minus, so negative integral of 1 over x minus 1 squared dx. And you kind of notice natural log is going to be a lot of this stuff, which is kind of the case. Again, I'll show you guys an example why the tangent comes into play in a little bit, but that's pretty much what we're going to be dealing with as of now, right now. All right, so let's try this out to finish this really, really long question here, right? All right, so same thing. So let u equal 3x minus 1. Therefore, du is equal to 3x dx, and it's going to be 1/3. Du is equal to du. So again, this is natural log, integral of 1 over u. So this first process is going to give you 1/3 natural log of 3x minus 1. And you can kind of guess, we did this earlier, kind of like the last example. It's going to be the same thing. Let u equal that. So therefore, du is equal to 1 dx. So again, it's integral of 1 over u. So minus 2 natural log of x minus 1. And this is the only one that's going to be a little different. So this is let u equal x minus 1. Du is still 1 dx. So this is integral of 1 over u squared, or u to the negative 2 power. So taking the integral of that gives you, if you add 1, u to the negative 1, negative. And we know negative makes a positive. So q x minus 1 to the negative 1 power plus c is our final answer. Lots and lots of work for those portions. Okay. So now let's try this example here. So this one actually is a pretty scary one when it comes to it, and I'll show you guys why. It may not look bad, but you know, this again, like everything else, the setup is the most difficult part to do. So let me do a start from up here. So first is already broken down, which is nice, right? However, it's x squared plus 1. So we're going to have ax plus b over x squared plus 1. Right? It's unfactorable because it's plus 1, not minus 1. And then we're going to have cx plus d over x squared plus 1 squared, like that. Horrible, huh? Okay. All right, so now we got to find 4 numbers, but now we have x's on top to deal with, right? But integration is actually not going to be too bad for this one, and you'll see why. Well, it could be, depending if you like it or not. But I'm sure you guys have hated it anyways, right? So what do we multiply this to get? Essentially that is just another copy of x squared plus 1, and notice here I have everything I need. So it's good and bad, right? Because I don't even have to do anything here, so it's kind of a one-step process. So we know that x squared plus x plus 1 is equal to ax plus b times a copy of x squared plus 1 plus exactly that, right? Because there's nothing I need to multiply to get this. I already have everything I want. All right, so again, we just got to distribute here. So I'll just quickly do that. I'll leave it to you guys to actually FOIL. But you should get this after you FOIL everything out. And we get that. Okay. All right, so again, putting everything together. X to the third plus bx squared plus ax plus cx plus b plus d, right? All individual ones. And notice we don't have an x to the third over here. We just start with x squared. So we know right off the bat 0 must equal a, because there's no other term we can do it, right? So that's even better, right? Automatically got 1 off the bat without even trying. So we know also x squared, so 1 must equal b. Even better. There's 2 out of the 4 we actually need without doing much work, right? So maybe this wasn't as hard of a problem as I thought it would be. All right, so now we go to single x's. So we know that 1 is equal to a plus c. And then finally, we also know that 1 is equal to b plus d. But notice you may think, okay, that's kind of weird, right? We have to do that. But we can use the original ones we had before here, right? So for example here, solve for c, we know that 0 is equal to a. So if I just plug in 0 for a, we get c equals 1. So we get that. And same thing applies here. So if b is equal to 1, I solve for d, subtract it. So therefore, 0 is equal to d. Oh, so nice, right? I wish every example was like this. So maybe it's not as horrible as we thought. So let's just quickly just draw this out, write this out. So we know that a is 0, b is 1, so we actually have the integral of 1 over x squared plus 1 dx plus, okay, c is 1 and d is 0, so we have integral of x over x squared plus 1 squared dx. Those are 2 integrals we have to deal with, okay? Now you may be wondering, okay, this is not natural log, right? Because that doesn't really work out. So how are we going to do this portion here itself? Good news is we have our handy dandy trick, which is right here. So we know integral of 1 over x squared plus a squared equals exactly tan inverse, and that follows the same template as the first one, because 1 squared is the same as just 1, right? So we have that formula. So that's how we can use this to help ourselves out when it comes to this section. Okay? So we know automatically, again, just for this first integral, that a is going to equal 1 in this case, because that's 1 squared gives you 1. So if we follow that template right here, is going to be again, going back to our scenario, 1 over a, or just 1 over 1, which is just 1. So that's tan inverse. And in parentheses, x over a, or x over 1, or just x. So that one is just that. Look at that. Just knowing that property saved us a bunch of time because you got to go over and over and over and not knowing what in the world we're actually dealing with in this case. Okay. All right. The next one isn't that bad as well because we can use U substitution for this case. So we'll let u equals x squared plus 1, just the inner portion there. Okay. So let du equal 2x dx. And notice the x is perfect, so therefore it will be 1/2 du is equal to x dx. All right, so going backwards, so this can be integral, or let's put the 1/2 outside, of 1 over u squared dx, which we've actually already did. Okay. All right, so therefore, this is going to be equal to 1/2 minus u to negative 1 power. Right, so if we go back over here, so plus, so minus, because it's negative, minus 1/2 u, which is x squared plus 1 to negative 1 plus c. So I guess it wasn't that bad as I thought. Pretty good, huh? Right. And there we go. So again, the best part is just remember it. And again, this process can always go, it's x squared plus a squared. So x squared plus 25 plus 9, anything like that, automatically gives you the tan inverse as long as you're being identified what the a value is going to be there. So I guess this wasn't too bad. That was actually a pretty smiley face, right? Much easier than the actual other one we've done so far there.